Good day. So we've been looking about the Hadoop ecosystem components. Let's see about MapReduce, Hadoop distributed file system, X-Trace, IO, and patches path. And we will also understand what about the features they have, the benefits, the limitations, the limitations. This is the last topic is highly X-Trace and start. How exactly they different from the traditional relational database handling system like MySQL. You also see with respect to the these features, how exactly are they different from each other, and how Spark has been really beneficial in the recent times and various media and portals. Spark has been replaced effectively. So we'll see the other modules of the Hadoop ecosystem. So the core components are powerful, but they are golden. The ecosystem provides higher-level tools that make it easier for developers, analysts, and data scientists to work with the data. We are now going to look at the most important modules within this ecosystem, categorized by their primary function. So let us take a scenario. Analyze website clickstream logs to find the most popular pages. So interesting. Let us take Flume. Flume agents on web servers collect log data in real time and stream it into Hadoop distributed file system. So Hadoop distributed file system stores the raw log files in a distributed fault-tolerant manner. Spark, the Spark job runs on the Yarn cluster, yet another resource leadership cluster. It reads the raw logs from HDFS, cleans the data, parses it, and aggregates the page view counts. The processed results are saved back to Hadoop distributed file system in a structured format. I Impala. The business analysts use either Hive or Impala to run the SQL queries on the processed data to generate reports on the most popular pages. Oozie is where the entire process from ingestion check to the final start job schedule to run daily using this Oozie workflow. So to analyze the website clickstream logs to find the most popular pages, starting with ingestion through Flume, storage with Hadoop distributed file system, processing with Spark, analysis being done with Hive or Impala, orchestration is done through the Oozie. So the other components or other modules of Hadoop ecosystem. One is NoSQL database like MongoDB or Cassandra. An open source NoSQL database for handling big data. It was initially developed at Facebook and it was later open source. Cassandra is designed to handle large amounts of data across many commodity servers, providing high availability with no single point of failure. It uses a peer-to-peer architecture which allows it to scale horizontally and easily handle increasing amounts of data in traffic. MongoDB is a big data tool that's most compatible for users who work with data that changes often, such as sales or engagement information and unstructured data. MongoDB can store large amounts of data from various applications, product catalogs, and various other data platforms. So that is about one component of Hadoop ecosystem known as the database. Other one is Pig. So Apache Pig is an open source platform for data analysis and manipulation of big data. It was created to make it easier for developers to process and analyze large amounts of data. Pig provides a simple scripting language called Pig Latin, allowing developers to write complex data processing tasks concisely and easily. Pig translates Pig Latin scripts into a series of MapReduce jobs that can be executed on a Hadoop cluster, allowing it to scale to handle substantial amounts of data. This makes Pig well suited for use in big data processing and analysis. So it is pretty much clear on the purpose behind this open source platform for the data analysis and manipulation of big data. Zookeeper is the coordinator making sure everyone in the cluster is on the same page, like who the active master of this. So it is Hadoop's distributed coordination service designed to run over a cluster of machines. It is a highly available service used for the management of Hadoop operations, and many components of Hadoop depend on it. A centralized service for maintaining configuration information, naming and providing distributed synchronization. Zookeeper for the distributed components, ensuring they are all coordinated. Oozie is the project manager defining a complex series of tasks, ensuring they run in the correct order and only when their prerequisites are met. It is a scalable workflow system. Oozie is integrated into the Hadoop stack to the coordinate execution of multiple MapReduce jobs. It is capable of managing a significant amount of complexity, ranging across events that include timing and presence of required data. Oozie allows you to chain multiple jobs together. Example, run as job, then on a hive job. So this is chain multiple jobs together and manage their dependencies. So Zoo being distributed coordination service and Oozie being the project manager to find complex business tasks. So as we have been saying, ingestion is the first step in any data pipeline. Sqoop is your tool for one-time or batch imports from your traditional databases. Flume is for the continuous real-time flow of data, like collecting live web server logs from all your servers and funneling them into Hadoop distributed file system. So Sqoop is a connectivity tool for moving data between relational databases, data warehouses, and Hadoop. So Sqoop leverages databases to describe the schema for the imported or export data, and MapReduce for parallelization operation and fault tolerance. The examples for this scope is relational databases, MySQL, Oracle, enterprise data warehouses, some of the instances. So the connectivity tool for moving data between relational databases and data warehouses. So Flume is a distributed for the continuous real-time flow of data, like collecting live web server logs from all servers and funneling them into HDFS. It's a distributed, reliable, highly available service for efficiently collecting, aggregating, and moving large amounts of data from industrial or individual machines to Hadoop distributed file system. It is based on a simple and flexible architecture and provides a streaming facility. It leverages a simple, extensible data model, allowing you to move one machine within enterprise into Hadoop. So the examples like log files, social media feeds, and event data. So distributed, reliable, and highly available service for efficiently collecting, aggregating, and moving large amounts of data from individual machines to HDFS is all about flow. So with all this said about the different components or the remaining components of the Hadoop ecosystem, like NoSQL databases and Sqoop, Flume, and Pig as well, we'll see if you are able to answer these MCQ questions. So the first question is a platform for constructing data flows for extract, transform, and load, which is ETL. Processing and analysis of large data set. So which one of these is a platform for constructing data flows for ETL processing, analysis of large data sets? The next question is, what is the primary function of Zookeeper in the Hadoop ecosystem? So the options are data processing, distributed coordination service, data visualization, machine learning. So we can take some time. The time starts now. I hope you have finished one question. So we'll go on to the next question now. It's almost time. Okay. So let us go with the answers. So the first question, Danish is a platform for constructing data flows for extract, transform, load, processing, and analysis of large data sets. So the possible options are Pig Latin, Oozie, Pig, and Hive. So they have listed out components of Hadoop ecosystem, and Pig Latin is a script. So the platform for constructing data flows ETL processing is Pig. So Pig is the platform for constructing the data flows for ETL processing and analysis of large data sets, which is not possible with Pig Latin, Oozie, or Hive. You got the answer right as Pig. So let's move on to the next question. So what is the primary function of Zookeeper in the Hadoop ecosystem? So the possible options are data processing, distributed coordination service, data visualization, machine learning. So primary function of Zookeeper in the Hadoop ecosystem is with respect to Zookeeper is not data processing, it is not data visualization, machine learning. So the right answer is distributed coordination service is the primary function of Zookeeper in the Hadoop ecosystem. So the first question, the correct answer is PIG, platform for constructing data flows for extract, transform, and load processing and analysis of data sets. The second question, distributed coordination service is the primary function of Zookeeper in the Hadoop ecosystem. So I hope you got the answers right. That is MCQ. So let us move on to the next section. So the descriptive questions. So we have understood what are the different modules of the Hadoop ecosystem. So with appropriate block diagram, explain the Hadoop ecosystem and its components. So we've been seeing various components of the Hadoop ecosystem. So we can take a pen and paper and review the time. So we can go ahead and start creating a block diagram that is having every component of the Hadoop ecosystem and provide brief detailing of each of those components. And you can just write the key points, but make sure to draw the block diagram properly. So your time starts now. We discovered the components, the brief explanation, the sketch, the whole ecosystem, still have the tools to work. So almost time ago, we were able to sketch briefly discuss the components. Okay. So let us begin the discussion with appropriate block diagram explaining the Hadoop ecosystem and its components. So we have to describe the components of the Hadoop ecosystem, and the block diagram should have that properly given in detail. So you can see the block diagram is having all of the components of the Hadoop ecosystem, distributed reliable storage, this Hadoop distributed file system. Then we have MapReduce, the programming model. Then we have NoSQL database, then enterprise data integration, and Flume is given. High level instructions, patch, fit, and patch, high. Then the coordination. Then we have the workflow coordination in the Zookeeper and the workflow which is Oozie. So this is complete block diagram wherein starting from ingestion, storage, data transmission, transformation, and processing. So every component with respect to the ecosystem is provided in this block diagram. So it is better to provide the basic definition on the Hadoop ecosystem. Then you can start detailing about the core components of the Hadoop ecosystem. So the Hadoop ecosystem is a collection of open source software, frameworks, and tools that are designed to process and manage large data sets. So it is a collection of open source software, frameworks, and tools which are designed to process and manage large data sets. It's particularly well suited for handling big data problems due to its scalability, fault tolerance, and distributed processing capabilities. So you can see how effective is this Hadoop ecosystem on handling the big data problems with features such as scalability, fault tolerance, and distributed processing capabilities. So while you're answering this particular question, you have to first detail on what is this Hadoop ecosystem and the reason behind its usage or the significance behind this Hadoop ecosystem. Then you can move on to the listing, mm, explaining on the core components of the ecosystem. So you have to begin with Hadoop in common, then it has to go with respect to Hadoop distributed file system, and then YARN, which is yet another resource negotiator, and then you can explain about MapReduce, other components just Apache Hive, HBase, Apache Pig, and Oozie, and Sqoop, as well as Zookeeper. So these are the core components to the Hadoop ecosystem. So after you explain Hadoop common, you have to state significance of HDFS and how exactly works in this Hadoop ecosystem and how exactly get another resource negotiators complementing the system, the significance of MapReduce, HBase, how is it different from the traditional relational database management system like Apache Fig, Apache Fig's ETL is extract, transform, load features, then how using Sqoop, Flume, and Zookeeper, also adding value to this ecosystem in this story. So on the whole, this particular question can be addressed with the block diagram explaining about the Hadoop in common, and then you can detail about the various components starting from ingestion, transform, processing, and the outcome. So that should provide justice to the solution of this particular question. So with that, we come to the end of this particular session on other modules of Hadoop ecosystem, wherein we will discuss about NoSQL databases, Sqoop, Flume, Oozie, and Zookeeper. So how they are adding value to this Hadoop ecosystem, and we will also try to solve MCQs and descriptive questions as well. Hope you were able to solve those minimum level of questions in MCQ and applying level of question descriptive. So it was about the system and its components and block diagram. So for more information on these the modules of the video system, you can refer this book, Big Data and Analytics. It's been published by Wiley Publication, the year 2020. That will come to the end of this. So thank you for your patience in watching this video. And I hope you got a clear understanding on different components, various components of the Hadoop ecosystem. So thank you. We will see in the session how exactly you get this installation of Hadoop successfully done. so that you can try and see how exactly it works and the different components involved in it as well. Thank you.